Welcome, Dr. Peat. Thank you again so much for being available to me. It's a great pleasure and privilege, to say the least. So what I wanted to discuss today, as I just mentioned to you before we started recording, are various aspects of what's becoming very de rigueur, very big now, is the ketogenic diet, in particular for dealing with cancer. And a number of other degenerative diseases. So the diet that, in particular, the guy who's written, I think, the best about it, although he is not a physician, he's a PhD biologist. You probably have heard of him. That is Dr. Seyfried, Dr. Thomas Seyfried at Boston College. Yes?
Yeah, I don't really know anything about him, but I've heard of him.
Okay, so he wrote a rather big book on all of this, where he was basically challenging, which I know is certainly in your ballpark, the genetic aspect of disease, and saying, no, it ain't genetics. It's the basic metabolic aspects of the body. And what he has been researching, and has quite a number of people now who are coming to these meetings on a yearly basis about the use of a restricted ketogenic diet, keeping the ketones up and the glucose down so that the ratio between glucose and ketones is in the nature of one. That is, the ketones, glucose divided by the ketone measurements coming to a ratio of 1, which is pretty heavy duty. And I've begun to experiment with that just to get a sense of what happens to my body as I use it. And I'm certainly noticing that when I eat too much protein, bordering on what would usually be accepted as good, that is about 1 gram of protein per kilo, my glucose stays too high and the ketones don't come up sufficiently. Anyway, what are your thoughts about that concept of the restricted ketogenic diet, and its possible good aspects, and what do you see as the deficits?
I think the basic worry is that the cortisol level is going to be kept up if you keep your glucose too low. But one of the things that there are quite a few publications on now is the ketone body ratio. And what they talk about usually as ketones, actually one of them isn't a ketone at all. And the ratio of these so-called ketone bodies, acetoacetate and I guess it's beta keto, butyrate. Something sounds wrong with the way I'm saying it, but anyway, the alpha beta hydroxy butyrate is the other one, acetoacetate and the beta hydroxy. And the hydroxy is a hydroxy or an alcohol, not a ketone. And the cancer physiology is high in the hydroxys, the reduced form, and low in the actual ketones. And what you want is the actual high ketone ratio, high ketone body ratio, keeping the alcohols low, because that goes with the NADH, NAD ratio being in cancer, the NADH reduced form is higher, and the lactate pyruvate ratio in cancer is high. All of the cell components shift in the direction of reduction in cancer. And so when you're starving or diabetic, typically you go heavily towards the reduced state of the cell because the fatty acids block pyruvic dehydrogenase, which is how you're oxidizing glucose normally. The Randall cycle, in which you have a competition between glucose oxidation and fatty acid oxidation, it's that the fatty acids which rise in stress block the pyruvic dehydrogenase, keeping you from oxidizing glucose. And this is the state of diabetes or stress or starvation. And it involves the failure to fully oxidize the lactic acid pyruvate pair or the NADH-NAD pair, ascorbic acid and dehydroascorbate. In the healthy cell, ascorbic acid is in the highly oxidized form. In the cancer cell, it goes the other way. So the whole shift of stress and cancer is away from oxidation towards reduction. And fatty acids are right at the center of that by blocking the pyruvate dehydrogenase.
Okay, well, in terms of just what you're just speaking about, as you know, I'm sure, Linus Pauling got really huge on vitamin C, and it was interesting that the NIH never gave him $50,000, which is all he was asking for, to do research on the importance of vitamin C. But how do you see his notion about, I think he was talking about 10,000 milligrams of vitamin C a day, and he didn't care what kind it was. He just said, they get the cheapest you can. How would that play a part in what you were just talking about in terms of that?
Robert Cathcart advocated taking vitamin C to bowel tolerance. And I said, well, laxatives are good, especially for cancer patients. And bowel tolerance means a cathartic effect. And I think that's a big part of those huge doses of oral vitamin C. But the metabolic effect of vitamin C, it is as an oxidant, since it's in the dehydroxidized form inside the cell. It's really functioning primarily as an oxidant, protecting the various apparatuses of the cell by keeping them, their folding, conformation, everything is regulated by whether they're oxidized or reduced. And so the oxidized state of vitamin C is one of the essential things for keeping the electrons guided away from disruption and towards the oxygen elimination.
Okay, so that would be also along the lines, if I understand it correctly, of what adequate maintenance of carbon dioxide in the system would do as well. That is, it would restore the proteins through the cardinal adsorbent property.
Yeah. Yeah, the vitamin C is doing it catalytically, actually moving electrons through it on the way to being consumed by oxygen and producing eventually the carbon dioxide balance instead of lactic acid. But the carbon dioxide, rather than being a catalyst in the sense of moving electrons, it's slightly retracting electrons from the whole protein system. And this is what St. Georgi visualized vitamin C as doing. He and Pauling talked about that a lot. And I think they agreed on that vitamin C was a very good candidate with its activated carbonyl groups as the equivalent. Carbon dioxide has its basically carbonyl structure, and vitamin C it's like an extension of carbon dioxide. So what it's doing is, apart from its catalytic movement of electrons, it's pulling partial oxidation, shifting the reactivity and the pH, or dissociation constant of the proteins, making the proteins more acidic. So the whole system is shifted to a more oxidized state. And in that state, sulfhydryls, that's the glutathione, the thiol group of glutathione, when you get oxidized, you get the GSSG structure rather than the GSH structure. So when you have the oxidized glutathiones or disulfide bonds, the cell is relatively locked up and tightly structured so that it runs like a tight machine. When you reduce it, get free electrons, and the dissociation constants and redox balance in the direction of the more sulfhydryls, then you favor dedifferentiation and the promotion of cell division rather than differentiated function. Dan Mazia, a famous biologist who just died a few years ago, was in the 1950s. His co-worker was a Japanese whose last name was Dan, D-A-N. But Dan Mazia and this assistant of his demonstrated that by staining for sulfhydryl groups, you can show that as the cell approaches mitosis, the disulfides shift to a very highly sulfhydryl reduced state. All through the mitotic process, the cell is loaded with sulfhydryl groups.
Well, now, we'd spoken before about, in particular, there's a huge amount, of course, that's been speaking about glutathione, but never in the detail that you're talking about. It's talked about usually as an antioxidant, and then N-acetylcysteine and alpha-lipoic acid together as precursors for your body to make the more glutathione.
That ideology has come up since the 1950s with Harman's free radical oxidative damage theory of aging. And that has its own history. Partly it was pushed ahead in around 1942, I think it was. Chickens and lab animals were experiencing brain and gonadal degeneration, softening of the brain and decomposition of the testes. And it turned out that it was a vitamin E deficiency caused by feeding them too much of the unsaturated fatty acids. And up until that time, vitamin E had been considered the anti-estrogen, anti-clotting, heart protective, anti-inflammatory vitamin. Suddenly, because of the brain gonad diseases, it shifted to becoming conceived as an antioxidant. And then those diseases associated with eating unsaturated fats and not enough vitamin E led to the thought that degenerative diseases preventable by vitamin E are therefore caused by oxidative free radical processes, where the other interpretation was that vitamin E was an anti-estrogen. The PUFA degenerative process was really a promotion of estrogenic anti-thyroid processes, and vitamin E was exercising its pro-thyroid anti-estrogen function. So I think the whole thing went wrong between about 1942 and when Harman wrote his famous article on oxidative theory of aging. So now glutathione, rather than integrating Dan Asia's work showing that the glutathione pops up sharply during the mitotic process and then disappears. You can hardly identify any by staining in the differentiated cell, but in the dividing cell, it's just like a black blob of glutathione, highly reduced. And if people had that image in their mind, that the healthy cell is oxidized with very little free thiol, very little free glutathione compared to the oxidized part of it, then people would not be so free about eating or injecting glutathione. I think it's likely to promote cancer growth, for example.
Well, and it's become, in many circles, as I'm sure you're aware, glutathione has become sort of like king, and taking a lot of the precursors like N-acetylcysteine and alpha-lipoic acid, are a big thing. And as you say, they have patches, glutathione patches, which are very expensive, which you put on to get more glutathione coming into your system. So that's it. Now, you've often spoken about vitamin E in many contexts. And so I'm getting that the protective aspect of vitamin E that you're talking about here is not directly related, if I'm correct, not directly related to the notion of a antioxidative effect, but rather as the anti-estrogenic effect. Am I correct?
Yeah, and anti-inflammatory, same idea, and pro-thyroid.
Yes, and what type of vitamin E, or doesn't it make any difference? Like the tocopherols are usually recommended, the big tocopherols. So, but what does it make any difference, or what vitamin E in particular?
As long as they're the dextro form, I think they all have overlapping functions.
The dextro form. I'm not familiar with what that means.
Well, D alpha.
Oh, D alpha. Okay, I'm sorry.
Not the DL.
D alpha. Okay, very good. All right. Now, I'll get back to what you were just talking about people having diarrhea from taking too much vitamin C, or the notion of bowel tolerance. What Seyfried, this is again coming back to Thomas Seyfried at Boston College, the biologist there who's written, pretty good stuff about the notion about the ketogenic diet. What he's saying is that's crucial is not too much protein and slightly restricted diet. Now, I remember some time ago you speaking about, or hearing you speak about or write about, that the notion that the low-calorie diet was so life-giving, and you'd see these people. I remember Seyfried has this funny comment, which he says, well, he saw a bunch of these people who there's a society for very low-calorie people, and he said they all sit around in meetings and share one grape. But if I remember correctly, you were saying that the key there was not necessarily the reduced calories, but rather, maybe I'm wrong, but it was something about vitamin B6 that you had spoken about in regard to, or something else that did.
Oh, well, there are several things that, the type of protein is really crucial. That's why I have talked about gelatin, because it's free of the sulfur amino acids, cysteine and methionine, and tryptophan. And these all these are the three potentially toxic amino acids. Cysteine is involved in excitotoxic damage of the brain cells. Tryptophan is in various ways pro-inflammatory. And just restricting a diet for one of these, either the sulfur amino acids or tryptophan. For example, a methionine-free diet extended rats or mice, I forget which, longevity by 40%. And a tryptophan-deprived or limited diet extends longevity and eliminates degenerative processes. And the other thing in a low-calorie diet, I think the main thing is less polyunsaturated fat, but also less of the heavy metals that interact with PUFA.
Yeah, well, now they also start quoting, which I know you've spoken to before, the China study. And in the China study, one of the things he's pointing to also is keeping the percentage of protein, complete proteins, low, but doesn't speak to this issue that you're talking about these specific ones, cysteine, malathion, and tryptophan, which raise also parathyroid hormone. That's one of the measures that you can look at.
Inflammation goes with parathyroid, but I don't think I haven't seen anything specific about that being studied.
What was there's a blood, I'm forgetting now, there was a blood test that, I believe it was a blood test that Danny has spoken about and you'd spoken about that had to do with parathyroid. And
magnesium, calcium, and vitamin D are important for keeping your parathyroid hormone low.
Magnesium, vitamin D.
And calcium.
Oh, right, and calcium. Now, milk, which of course you are very heavily in favor of people drinking on a regular basis. I'm starting to look at getting the raw milk, good quality, high quality raw milk in the New York area, which I think I've got a good source of. So milk, it doesn't present the same kind of issue. Milk and good cheeses don't present this issue as much. Am I correct?
I think it's that there are some peptides in casein that seem to be anti-stress, but I think mainly it's the high calcium content that pushes your parathyroid hormone down. And parathyroid hormone is a promoter of inflammation. And so then the tryptophan is effectively defanged by keeping your vitamin D and calcium high.
Yes, as I understand it from a conversation you had with Danny, that you pretty much kept your calcium levels up, consummation of calcium up to 2,500 milligrams a day on an average for many years now. Yeah, and most of that you're getting through the milk or?
Milk and cheese, and I think I probably on average get closer to 3,000 milligrams per day from other foods.
Now, of course, how does that match with the notion of the paleo people? But going back before that, with the China study, the notion that green plants, consuming green plants, a large amount of green plants, also provide that.
Yeah, they're great sources of calcium and magnesium. But the trouble is that green plants are the energy source of that plant organism, and they're susceptible to being grazed. And so the plants, liking to survive, put bitter and toxic components into the leaves to discourage grazing. And especially when they're raw, green leaves are very bad for the system. They damage the intestine and the ability to digest proteins, for example. And so the plant intends them to be bad food, but by cooking them and choosing young leaves, you can pretty well defend yourself against those plant toxic defenses.
Well, is that part of why the ruminants, like cows and so on, and horses, that they seem to be able to tolerate that stuff well because of the long time of digestion?
Well, they set it aside into the rumen and let bacteria and fungus break it down.
Aha, I see.
So, mammals don't contain the necessary, the plants outsmarted mammals in general, but then cows set up their own chemical processing lab using microorganisms to work.
That's wonderful. I love it. Okay. All right. So now, next piece about this ketogenic diet that Seyfried is talking about, and I'm resisting buying that book. It's too expensive. It's about $100. His big book. I'm trying to find more specific some other way about what he's talking about. But he's speaking about an interesting combination of the ketogenic, restrictive ketogenic diet, low amount of protein and calories, along with, of all things, hyperbaric oxygen. They don't know about the concept of reduced breathing, raising carbon dioxide to achieve a much better result. I remember you talking about that person who had it was a tumor, I think, in his throat, and they put him in a hyperbaric oxygen chamber with 5% carbon dioxide, and it just dissolved the tumor.
Well, it relieved the congestion enough that he could suddenly talk.
Yeah, and if I understand correctly, part of what was going on was that the idea of the hydrophilic aspect of the tissue, and then the water was just sort of let go by using the carbon dioxide to.
Yeah, the pH. If you take Jello and add soda to it to raise the pH, it liquefies. And if you acidify it, it contracts and gives off water. That's a general thing about protein gels. And the cell behaves exactly that way. Raise the pH, and it swells up and becomes reduced and tends to divide. And the carbon dioxide lowers the pH of the protein system, makes it simply squeeze out the water just like a jelly does it. A simple physical change. There's lower affinity for water.
So,
and the electrons are retracted in effect as the pH goes down.
So this is when you talk about estrogen, histamine, and nitric oxide increasing the structural temperature of the water and destabilizing the cell, and then progesterone, cholesterol, oxygen, and carbon dioxide have the opposing effect. If we're getting people to breathe less and conserve their carbon dioxide, it's the same thing is going to be happening.
Yeah, and if you look at the difference between estrogen and progesterone structurally, you see the same ketone groups in progesterone and the hydroxy group in estrogen.
Okay, so I think that pretty much gets us through the pieces about the ketogenic diet. And I think what's happening is that they've hooked onto something, but I don't think, at least that what I've seen so far, they don't have the explicitness that you're speaking about, which would probably lead them in a better direction if they understood that, because they're mixing things together. For example, you've spoken often about if you're going to eat animal protein, which is fine, do not just eat muscle meats. You need to use organ meats as well. And of course, an egg has everything. So it makes it a little bit easier because it's got everything together.
Yeah, the meat has a very bad ratio of phosphate to calcium, for example. I think that's its biggest drawback besides the high iron content, but it's just got a terrible excess of phosphate. Same as beans. Beans and meat are phosphate dangerous.
So you recommend for people, for example, that they have liver, beef liver, a couple of times a week, a modest amount, along with some shellfish. And you don't seem to have any concern about where that shellfish comes from.
Oh, sure. Argentina and Maine are probably still good. Peru.
Yeah, they have shellfish that you can get, which are called wild caught versus farms. But most people don't realize an awful lot of shrimp are being raised in shrimp farms, which are probably pretty damn toxic, the same way that some of the fish farms are.
Yeah, I think you definitely should avoid the sea-caught fish or shellfish from Japan and Korea. And there are many places around Europe where there's nuclear contamination as well as toxic effluent from industry. So the whole Northern European, I would say, would be avoided.
Yeah, I think that's I've seen many people quoting you about using shellfish, but they don't recognize that you're just as careful about, where the source of different good foods is coming from as anybody is. And I think that's important, but people just seem to latch on to just the idea, well, let's just get some good liver and let's get some good shellfish, rather than recognizing that you're pretty selective about, in fact, you notice how your system reacts to something that you're eating. And if it doesn't react well, you figure this is not a good thing. I'm going to look for another similar product.
Yeah, that has happened with organic milk several times. We had bad reactions and it tasted bad. And once we looked up where the dairy was, because it tasted so funny. And there was a military metallurgical factory up the highway, Huachang. And looking on Google, we saw that our organic raw milk dairy was just about a mile downwind from this horrible, stinking factory. And even though it was organic, it apparently had absorbed some of the bad smells from the industry.
Yeah. Well, there were that whole group of Hollywood actors, including John Wayne, who were doing movies, years downwind of the atomic bomb exercises. And of course, they died of cancer. Quite a number of them who were working on those movies that were working downwind of those explosions, which of course had huge exposure. Okay, so now if we could move on to, thank you very much, it's been very helpful. Move on to the whole thing that you and I have discussed, but I've not quite nailed it down yet, and I think I'm getting closer, to how carbon dioxide does function in terms of why people overbreathe and continue to overbreathe, which is obviously bad for you, versus people, once they've done the Buteco work, for example, or any form that helps you to reduce your breathing, and if you maintain it long enough, your body regulates itself, which may be because if you have sufficient maintenance long enough of carbon dioxide in your system, then the whole system, the proteins in the system are really well set up, and you don't have the stress. You can manage the stress much better. You're not going to get away from stress, but you can manage it much better if your body's well conditioned that way. And the notion that is promulgated in mainstream and in most of the practitioners Buteko's work and similar work is that it's carbon dioxide is not the issue, although that's important. It's the acidifying effect of the carbon dioxide going into solution that raises the acidity of the blood properly, not carbon dioxide itself that's making the difference. And so they then refer to the Henderson-Hasselbalch equation, which you pointed out is a little bit off, and talking about how, well, because of the blood-brain barrier, the only way you can manage things is to exit the excess from through your kidneys, and then you've got the problem, which is you're constantly remaining alkaline in your blood, and so you're going to overbreathe over and over and over again. It never quite made sense to me, and so I'm thinking that maybe it's more along the lines of that the body without sufficient carbon dioxide is in a spastic, that cells are spasming, that, you know, there's a spasming process that goes on.
Yeah, I think meaningless excitation is what a spasm is.
Yes.
And I think that's why at menopause, when women are overdosed with estrogen relative to the anti-estrogens, androgens and progesterone, estrogen is a nerve muscle excitant, and women at menopause typically hyperventilate. And one of the ways estrogen acts is to increase nitric oxide. And in the brain, nitric oxide, like histamine, is an excitant.
Yes, you covered that beautifully in the last two newsletters, where you wrote extensively about the various aspects of nitric oxide. And I think that's really vital for people to really understand that, because it's along with what I'm talking about just right now is, so if carbon dioxide is low, then you have this, as you say, toxically functional spasming, and the system can't quiet down. And if it can't quiet down, then it's reaching for oxygen, which is not getting out to the cells and tissues. And so you try to breathe more, to breathe in more oxygen, but when you're kicking out carbon dioxide more and more, you can't utilize the oxygen. So the system is constantly in spasm.
In my last newsletter, I talked about the coronary artery spasm that causes angina pains. And there's one type of angina that comes on during the night when you're not exercising, but when this spastic state is being increased by stress.
Yes. Yeah, I've twice, unfortunately, I was in, tremendous stress in my life a couple of times. And one time I started to have angina. Now, being a Buteyko practitioner and having seen somebody stop a heart attack, one of my early teachers, I knew what to do to stop it, and I did. I just reduced my breathing drastically, and the angina went away, but I was terrified, and I went to the hospital. Unfortunately, fortunately or unfortunately, I can't really say, they put in a stent, and it was the wrong kind of stent, the new stent, which didn't ever get pulled into the endothelium, so it was sitting out there as a kind of an edge to get things, and it happened again. I rescued myself by doing reduced breathing, drove myself to the hospital, and as I came into the hospital, I said, hello, I'm having a heart attack. And what they did was they put another stent in the same place, spread it out, but they used the older stent, and that one has been absorbed into the endothelium, so there's no longer that edge that's there. But it was reducing the breathing dramatically, which then allowed the vessels to expand and open up a bit sufficiently so that I didn't have, the worst effect of what could have happened. And that, go ahead.
Carbon dioxide should be the vascular relaxant. And when you're well saturated with carbon dioxide, you don't need the emergency nitric oxide dilator, but it simply relaxes your capillaries and arteries appropriately so the heart doesn't have the resistance, can pump a lot with very little work.
Yes. So early on, when Teresa Hale, I was helped. Teresa Hale is a woman who has the Hale Clinic in England. It's the largest alternative health clinic in the world. And she came to the United States and contacted me. This was about 1999. She came here thinking she was going to open up another clinic here. And we were talking about the Buteyko work with one of my original teachers. And she said, we should talk about the hidden secret, which is when your breathing gets much better, your erectile function gets much better. You don't need Viagra. That's been a piece that's come along there. But we don't talk about it much, but it should be talked about. I've had clients who, after they've worked with me, have said, the flagpole is up. Now I laughed because it was a similar statement that was made in the video with the China syndrome piece for one of this lovely man. So I think maybe in this I'm getting closer to I think what really does happen, which is this spasming as a consequence of low carbon dioxide. It can't function adequately as a cardinal absorbent. The entire system is in a destructured, destabilized circumstance. And so the body is crying for what it can't get. And so it gets you to breathe more and more and more and continue to do so. And the only way to really stop that, two things. One, now you have talked before, I tried it, but I wasn't successful at it, of taking carbon dioxide in a canister and putting it into a plastic bag and wrapping it around. You said you and your wife, every once in a while, you sit around with a bag. And I wasn't very successful at that. I guess the carbon dioxide was escaping or somehow I wasn't getting enough. But the idea there was that you were getting it absorbed through the skin. And similarly that, you could probably take a bath in sodium bicarbonate. I don't know.
There was this old article, I think about 1908, a guy was praising the effects. He said it was like a vacation at the beach to take a bath, just fill a bathtub with it because it's heavy, and sit in the bathtub for half an hour.
Oh, you mean he just poured carbon dioxide into the bathtub since it's heavy, it stayed down there? Wow, that's cool. Well, that if you don't move to get nobody to move around in the room so you don't get any stirring of the air.
When you handle the bag, you fill the bag and you can feel it. It's very heavy. And so you have to hold the bag open and step into it like you're climbing into a tub. And then when you get into it, you tape the neck shut so it doesn't squeeze out.
Now, as I said, I wasn't successful at that. You need a pretty damn big bag. I got one of these great big leaf bags, but I just didn't get enough carbon dioxide into it. And of course, you don't want to have it.
You have to start with the bag squeezed empty, and then fill it up so it's pure CO2.
And also
you get into it, you can feel it, especially on your crotch where the skin is sensitive. It's hot immediately. You can feel it soaking right in.
Yeah.
And you get pink after about half an hour, and that pinkness lasts usually for a few hours, meaning that your body is pretty well saturated.
And I would assume that you don't want to have any clothes on when you do that.
Doesn't matter. It goes right through the clothes.
Oh, cool. All right. Very good. Because I was recommending if people wanted to try it that they should be very comfortable with being nude with somebody else. Okay. Well, Dr. Peat, I just want to thank you. This has been very informative as always. If you don't mind, I would like to send a copy of this to Danny Roddy. And what Danny wants to do is to put some of these on YouTube. Would that be all right with you?
Yeah, I think so.
Okay.